Today we have presentation class lecture with Mr. Poppy. So he is going to be present for his lecture. Thank you.
Multimodal learning and foundation models. Yeah, but let's discuss on this kind of outline. So firstly, I have to explain what it is exactly, and then some kind of architectures and some alignment inside. How do you evaluate this kind of systems? What about the risks and then the ethics and everything? And also what imaging trend that you can follow for research and industrial purpose also. So, but when they talk about multimodality, always you think about at least some kind of text, image, video, and yeah, some many data types, sensor stream, because we try to always define some model like this. So we have some model like this that takes input and then produce some one output. Generally, it takes just one thing. It can be just an image or a text, most often. So I have my model here, image classification model. So I put some image. If it's classification, then I have some class 1 and class 2, for example. Yeah. So generally, it's trained on images, and then you give an image, and then it gives some class, for example. Or if it's some kind of predictive regression analysis, it can give a value or whatsoever. But however, it's trained using just one modality. So the modality here refers to a data type. It can be a text, it can be some image, it can be some video, and so on. So normal training is just one data type, then you refer to a single modality. What we used to do in most cases, so like image processing, we don't combine. But now, multimodality means you are combining more than one type data. You don't just focus on time series, you don't just focus on image, on text, on audio, but you want to use some multiple modalities. So multiple modalities, multiple data type, yeah, that you combine to get something. And why do you have to do that? Because it helps human cognition to integrate multiple sensory data, for example. So you can handle many things at the same time. With different type even. That's much more important. Different type. We don't talk about feature, we talk about data type, like combining images and text, combining text and video, and so on and so forth. It also makes some kind of robustness. So when you have one modality, can be compensated for noise and some other things. So it's more robust if you do some, you will see in front, kind of alignment. If you have some good alignment, you have more productive results with multimodality. It's example, some people now try to do not just image, they do image with interpretation, NLP, so it makes it more interesting for everybody, not just you, not just me. So even medical doctor also can use it. So expressiveness. So you have some cross-modality semantic that can lead to richer representation. So when you combine this type and this other type, it gives some more strong representation. But how does it work normally? How it works is that we assume that you have some input set like this of modalities. So modalities represent the various data types like text and image and everything. So we have this set here. So the goal here is to have a particular model. This model will be able to take any data type and give an output. So it will be different from this single modality that takes one data type to give the output. In this case, it takes, you have, like this, if you have two modalities, you have a function like this that will give specific output. Yeah. But what happens in this case, so there are some kind of operation that happens in multimodality system. For example, you have some kind of fuse information, like they call it a fusion task, and then you can have some translation between modalities. Yeah, that's translation task, and then you have retrieval, one modality from another retrieval task. I think we'll see it detailedly ahead. But you can see from here that this is what they call unimodal. What you know normally. So you have some prompt in text processing. You ask him to generate describe a horse, and then you send it to your model, and then everything is trained, and then you have this result. So from text you have a result. This is one model, single model. But when it's a multimodal something, you describe this picture, you provide the picture of a horse, you do something. So you have some different things here that goes here, and then try to give some output, maybe with some sound and something. But however, you send in more than one modality. You have, for example, an image, you have a text that you have sent, and then you send it to the model for prediction. It's same like here, where you have a single model in AI, and then you have a multimodal AI. So here you just have a single data type. This is a traditional model that we always do. That comes here, and then, but here you can have some combined. Then you have a multimodal model, and then we give you some greater variety of outcomes. It's still same everywhere. So you have your model here, and you have different type of input, video, image, and text, and it gives you multimodal system. Why is it so important to do? It's important because if you succeed to combine some various data sources, you have more informative features, and then you make more concrete decisions now and predictions also. So what are the categories? The categories of multimodal task here. So I talk about some fusion, translation, retrieval, and then some other type. For example, in terms of fusion, an example is visual question answering. So it combines multiple modalities to make a decision, for example. And then in translation, you have the DEL model from OpenAI that make the text to image. So you convert one modality to another. Originally, you give some prompt, which is a text, and then you expect another one. That's kind of translation from modality X to Y. And then you can have retrieval. Retrieval means maybe from an image, you have a caption with clip. You know about clip? Model. Yeah. So you can find some matching modalities. But it's one big challenge also that you will see is trying to match some different modalities is a problem also. Yeah. So you have a zero sort and few shot depending if the model need to learn on small or large amount of data. And then another way to classify, you have some examples here of family models. Yeah, models family, for example. So you have clip here, and then you have GPT-4, for example. But you can look carefully the kind of backbone architecture that they are using. Yeah, here you have a dual encoder, and then the kind of modality. Here is text plus image, and then for GPT-4 is text plus vision, and then you can also have some kind of. For now, the backbone is not released, so it's unknown, and you can have the type of vision mechanism. Yeah, how do they combine this to make a decision? For example, here they use the contrastive loss, and then in other words, they use the cross attention. I think we'll see it here also. Yeah. So theoretically, there is kind of a mutual information. So the mutual information can be framed as maximizing the information between pair data. So if I have a set or a modality X1 and X2, the first thing when you want to make a kind of multimodal, you need to extract the maximum intersection between the two. That is why it's just being represented as the max between the two sets. Yeah. And how do you do to estimate, for example, this methods? You use, for example, the contrastive loss. You know this, you must know it, because it's very famous. So you use it, and then this is a cosine similarity, and also the temperature scaling. You can have this from the contrastive loss paper. And what do you gain when you do this? Once you do this, you can work with big labels. It means if the data is not fully defined, it's also good. Yeah, because it's a problem to have labels. Yeah, so big or no labels, you can easily conquer that. And also, you can make some shares structure across some modalities. Let's look at the learning view representation. Yeah, this how the multimodal learning is being represented. So the main objective is just to learn and share some kind of latent space where the representation from different modalities are aligned. So assuming that I have some modality X1 and X2, because I have a larger set here, X1 who has some, X1 on to X10, and then I have the second set and so on. So I take some modality X1 and X2, and I have a first model here, another model. What I'm interested is the output to talk about, because there must be a kind of connection. Yeah, so the two output, when I run this and I get this, I run this and I get this, the two outputs supposed to be similar. If they are not, then there's no way to say that you are doing multimodality. Yeah, so you must try to get the space that they share together. Yeah, so the properties, for example, have to be some kind of invariant, so it must be robust and irrelevant to modality specific changes. And then you have some other properties, but always, in all the cases, make sure that the output from each model can have something they share together, so there's some kind of join. So, because if you have a text model and then an image model that are not linked, or maybe some two sets, and what do you want to do? It becomes totally separate. So multimodality, mixing more than one modality, also try to get some shared space inside. And this comes with a lot of challenges. So one of the challenges here, you have some multimodality heterogeneity. So some different modalities have different statistics and temporal structures and then information density. So they are so distant. Sometimes it's hard to make connection between the two. Yeah. So this is a kind of challenge when you want to engage into multimodality. Sometimes the modalities that you are joining are not having a strong intersection. So they are not really sharing. There is no, this equation is not verified. There's no big similarity. Sometimes the similarity is low between the different output, and then it makes it more complicated. So this is one thing. And sometimes you have some missing modalities. Missing modalities means that there's no modality that are always present in real world data. So sometimes some noisy audio or videos and missing sensors and so on, or even some alignment problem. Alignment means you have some data that are not paired from two sets. So modality X1 and 2, but they are not pairing, for example, or some weak data that are not weak or noisy corresponding data, like that. So these are some challenges when you venture into multimodality. Other challenges can be, you can see here, that the amount of data is increasing. Of course, it will take more computational complexity now, because you are handling more than one thing. And also we talk already about data alignment, some space and missing data, decision making also complicated. Because you have the process in this model, how to make a decision with one modality. So combining also makes the decision making complex, not impossible. Okay. So let's look at architectures and training paradigms for multimodality. Yeah. So we talk about the core architectural strategies. So I have modality-specific encoder. So each modality process is processed through a separate encoder. For example, in a multimodality setup, you can combine the text and the image and audio. Yeah, so for the text you can use a transformer, for the image you can use some vision transformer, and for audio you can use some ResNet or maybe some CNN. So there's a kind of latent vector that you have to align all the fields downstream. So you must make sure that at the end there's alignment. Alignment means matching the modalities. Yeah. Another strategy is the joint embedding. Yeah, so both modality projection into a shared representation. Yeah, so in this case, you can see it supports some zero-shot classification or some retrieval process that we saw already. Another one is the cross-attention fusion. But the cross-attention fusion is defined in the attention mechanism. You have the formula there. So with a query, a query modality attends to the feature from another a query modality. So you have to compute the attention mechanism to see how related they are. And you can also use unified transformer for all modality tokenize and input in a single transformer. Yeah. In all the cases, if you use unified transformer, then some benefit is like simple interface, for example, and then token alignment, transferability. In terms of training objectives, you have to always try to get a minimum loss function. Yeah, so, and then the loss is defined, so you know the contrastive loss already. Yeah, and then you also have the generative loss. So very important, fundamental papers already, you have all this in. If you are doing NLP, you should, even transformers also. These are very fundamental expression, but always you have the cosine similarity and then the temperature and so on. So yeah, the goal here is to align the pair embedding. So if you use the constructive learning, which is self-supervised method, yeah, you can also achieve multi-similarity, multi-modality, yeah. And then there you have, you can express the loss function like that, and then you promote discriminative embeddings, and you can use zero shot or cross modality retrieval, yeah. And then for generative learning, the goal here is to model conditional generation across modalities. So you have the loss function in any way, because when you always apply it, whether on paper or whatsoever, they're always curious to see what is the loss function. Yeah. So maybe if you just reapply self-supervised learning, contrastive learning, you have to use the expression that was defined in the contrastive learning paper, for example, but always you have to do like that. And then, but the generative loss is being used in the DALI. You know the DALI model from OpenAI, and then some other model. Another training objective is multi-task hybrid training. Yeah, so here you have to blend constructive and hybrid means you are combining more than one thing. So you can combine constructive and generative, and maybe max objective. So you have some kind of comparison table for multimodal foundation models. So we have some foundation model and the type of modalities, and then you can see the type of objective. What are the loss functions that they're using? We already presented the architectures and then some key features there. So you can look at them carefully. But however, what we try to raise here, like attention, is that you should a little bit forget the idea of running always a model on a single modality. I think it's going to pass already. You must use more than one modality right now. So if always they ask about some kind of changing style and then making new research, it therefore means that even if you were working just on computer vision, then some model development for computer vision, why not thinking about adding some other modality? It may be some text, yeah. But in practice, when you try in the beginning, you want to you don't want to handle it as a multimodality problem. So sometimes you want to do it sequentially. Sequentially means maybe you want to do the prediction from the image. Before you do the prediction, you take that result to continue. Alan, you see, we tried already like that. So we don't want to combine those two sets. We want to, first of all, use a computer vision model, and when we have the output, we continue with it. Yeah, but with multimodality, actually, it's kind of combining the inputs, and it's more innovative. So if some data set is being used 2,000 times or whatever, I think as we discussed last time, you have one way already to explore explainability For example, another way today that I'm showing is that you can use multimodality. So adding one more modality to your model training. And in some people already are doing, I think NLP, they are really doing most things like that. But computer vision, you can do that also. Yeah. Then in this case, you need to have some key consideration, like maybe some fusion strategy, because we talk about this on pre-training, freezing language models if you're in NLP, yeah, and so on. So you have some kind of key design consideration when you are doing this, yeah. But let's talk about something very important here, because we mentioned that if you have two sets, like S1, which is an image, and X2, which is a text, yeah, you need to do some kind of alignment. Alignment means a matching, for example. Yeah, but how do you, because it's a big problem now, and we also mentioned in challenges that it's a big challenge, yeah, to match this representation. So we have to look like how does it go, for example. So we define the multimodal alignment like ensuring systematical similar input from different modalities. For example, image and capture. And then you have to make sure that they are mapped to nearby representation, and then they share some coordinate space, some kind of union in these two inputs. Make sure. Yeah, this is what they call alignment. So if you do that, it's easy to embed cross-modal retrieval. Think about ChatGPT. If you take some Korean image, if you have chat maybe 4.0 that has 4.0 has a DAL inside, image model, you send some Korean image and you ask an English question, he answers. Because he supports this kind of alignment. Translation, he answers because you expect him, first of all, to understand the image and maybe answer in English, but above that, he can still do in another language. So he mixes a lot of things inside. Yeah. So it makes that there's some kind of cross-modal retrieval. So I can remove from the text and then go for another thing. Yeah. So it supports some kind of translation. I can move from text to image to another language, and so on. Yeah. So allows also fine-grained and decision-making process. How do you do this alignment? You can use, for example, constructive learning still. You see, it's fundamental. So self-supervised learning becomes very fundamental. If you didn't request for next week class, this is what I think is very important now. Because it goes everywhere. We need to understand how it works. So, yeah, if your request is less important than this, maybe we have to cover something about this next time. So the constructive alignment is very important. It uses the same constructive learning laws, and the goal is to align the paired representation and separate. You remove the non-matching sections apart. So you focus on what is matching. Yeah. And you see, for example, if you have, like in the constructive learning here, you have still the constructive loss that you have to evaluate, and then you have the output for two different. So this model is trained for the text and this model of image. But you make sure that there is some kind of alignment matching between the Z of the input, the output of that model, and the other one to make some alignment. Yeah. So this is good because it's fast for inference, and then the limitation is that sometimes you have no detail of grounding alignment. But if I say grounding alignment in weakly supervised learning, at least you understand. It therefore means that it was partially, you have some partial annotation because the ground truth is not fully defined. Yeah, in all the cases, whether it's image or text. Another approach is the cross-attention alignment. Cross-attention alignment, you have a few models there, foundation model that use them. Yeah, so this one uses one modality as contextual conditioning for the other. So you use one modality, like text to image, region, grounding. Yeah. And this architecture uses one modality is used to compute some kind of query. But it's still the same thing. You see that at the end, you have that transformer attention mechanism that is always everywhere, and then the similarity loss, cosine similarity, and everything. So it becomes a very complicated for you to do without understanding. You know the paper, attention is all you need, and then contrastive learning and so on. Yeah, you must try to read them and understand. And also follow some YouTube videos and some blogs. They already explain, like on white paper code like that. You can get it very well. Another alignment approach is the shared embedding space. Yeah, the shared embedding space, and then you have some other alignments like I try to mention there. So once you've done alignment, you need to do some kind of evaluation. So evaluation, because we do, even for this model, when it's in a uni modality, one modality we always do, but once you combine, it becomes more. You also need to evaluate in all the ways. Are you sure? And then think about explainability. You must show that it's real what you are doing. Yeah, so some metrics are defined here. So you have the recall, for example. This gives the percentage of true pairs found in the top tier results. It means that if they remove and then you look, how many percent is true? And then you have, for example, accuracy. Accuracy is always the same everywhere. And then some, yeah, crossing purity and so on. Yeah. So you can use this matrix to evaluate your alignment. For example, evaluate alignment. Yeah. But still there are some challenges. Challenges because of weak or noisy pairs. Weak means it's not fully defined. You don't know exactly to which class it belongs and so on. So how do you make alignment? Alignment is a little complicated, especially in real-world databases. Yeah. And then there's also modality imbalance. You see, when the present always they say there's imbalance, but I feel that each time when you start an experiment, don't focus on imbalance. You are not in the company. So if you come in the data set, try to look for the portion that functions for you. Don't use it, say, I downloaded and the data was imbalanced. Just take, if it's 100 minimum, forget about the classes that have 2,000 in the beginning. But in real life, you can have this situation where you must handle. But if you just want to test something, you can just cut the part that is good for you. And then you try with it. Not to say you have to use this or that to try to do some other thing. But there's also some kind of semantic mismatch, some challenges here. So sometimes some modality specific, there's some kind of bias, like a color image versus abstract language. Sometimes it's semantic mismatch, so it doesn't correlate well. It's same like you ask a question and then they give you some kind of weird answer. She has that kind of situation also sometimes. So in this alignment, these are some kind of things you can check in alignment. You can imagine trends and recent papers. I didn't put some references, but you can check on Google. So because I don't know, if I put the reference here, I feel it's maybe, I don't know if I have to put it behind or, yeah. So it complicates a bit in the PPT. But all this you can check to see recent work, 2024, 25, like that, people are working on. So you can focus on alignment, aligning multiple modalities simultaneously. So if you want to engage, because remember also, you need to know what we do or what we are doing. What part of AI do? You need to know clearly. Because I feel that if a student here wants to do alignment of multiple modalities simultaneously, he can do like in apply AI, meaning what? You find a case study that will use this concept to be solved. But if you want to solve this as a scientist problem, then it takes maybe all your PhD time, 4 years, to write something significant on this. But we do apply science, so maybe you just find your, I don't know, some text and image and everything. Then you try to align multiple modalities at the same time. You do some experiment and see what it gives. Yeah. But if you want to handle this like a scientific problem, maybe after 4 years you are still working hard on it. I hope we do so. Yeah. We understand. So we mostly do application. And there's also grounded alignment. Grounded alignment, so alignment without a bounding boxes or sending graph, and then some cross-lingual modality. But this one exists already little on some advanced model like GPT-4 all does this already. So you can send some English caption and then it will give you some Korean description, for example, and all these things. So these are the kind of emerging trends. And if you look at this carefully, you see that it would be really meaningless today to say, I really do just computer vision. It's even a mistake to say that. You just need to be open to all data type. As most important is, junction. Multimodality. I find this very important today. Yeah.
In the alignment case, it will focus the required features and ignore the other things rather than exist in that as well.
Requires features on the matching, not require. Matching features. And then remove the the other ones. On the matching features. So just a few minutes ago, I was talking with Haider Ali about his proposal, but you will see his project. You will see in his project he's already fortunate. Why? Because he's using two sets, some image and text, but there is already some ID. There is a link. There is a link. But think about, then it means his data set is already aligned. He's not solving alignment problem. He's taking the intersection of this. He's using this already. Two data sets already aligned. So there is an identity. For this image they gave this text. For this image they gave this text. But others, what we do with Allen is not like that. Sometimes you have to do the matching by yourself. So, but we can avoid. So we avoid, like, we first of all finish with the first model, and then we continue with second. Sequentially, but it's not the way. Even though it solved the problem, it's not the way.
I have one. What if my input is audio? Sometimes the pronunciations are same. So how will it give me text message? How will it identify that I'm saying this one?
It's basic. The accent is a problem today in audio everywhere. It's always been a problem because the speech recognition algorithm, whether from Google or whatever, uses a native speaker accent. It can never be accurate.
That it will eliminate irrelevant things.
Yeah.
But if two pronunciations same, how will it identify these?
If it's same, it means that it's matching, so there is alignment. But once it's not same, you have to remove.
So
You
is
see.
there any limit to input data?
They said it's a challenge.
Right intersection.
Intersection. It is a challenge. That is difficulty that you will face. Yeah.
I want to ask one question. Like, we know multimodal, the basic version, and we know generative AI. But now we have multimodal generative. So, like, what's the difference between generative AI, the basic one which we have, and the multimodal generative AI?
But you get multimodal.
Yeah.
You understand what it is.
Yeah.
And the other question is,
Generative AI.
can you understand what is generative AI? But it's different, it's clear. Just tell me multimodal.
I'm asking about
The difference.
Multimodal uses generative AI. So why we need to use generative AI, like the basic one? If we are using multimodal generative AI, why we need to use the generative AI? Like, what's the point I'm asking about?
So you have Gen AI here. So you're asking why you use multimodality. Gen AI is only built on multimodality behind, because here you have what? Text, image, video, audio, and so on. So there is no way you can pretend that you are doing generative AI without these things. So multimodality is the architecture, the technology that generative AI uses. You see?
The main question is like, right now we have multimodal generative AI.
Yeah.
So why we are using the generative AI, the basic one? If you
What is generative AI?
It's like you can create a Unicode, something like if I only want a text, I can do bigger. If I only want an image, I can make it.
Yeah, data, yeah.
In multimodal, we can do like multiple
Combine,
things.
yeah.
So if multimodal can already do generative AI part, so why we need it like separate?
Generative AI, why you use separate? G,
But to be honest, I don't understand her question. Can
said-
somebody understand the question?
He said, why we use generative AI alone, but we have, other than we have multimodal generative AI.
Like we can use multimodal generative AI and we can do everything. But why we are using
Ah, okay then. I understand. See.
Yes.
Him. Shingwe did some experiment about they are working on something about color matching. They have no data at all. So he uses Gen AI to get just that data, single data. So if you want single, you cannot always say that you only use multimodal. No. In his case, he's using Gen AI just to get single color data.
I'm also going to use generative AI, that's why I was asking.
Yeah, I understand. That is why I think you are topic you must use some multimodality. I think so.
But,
Or
yeah,
or physiologic also. Yeah, if you don't have a data.
that's why like I was asking like if we already have multimodal gen, like why we need the specific gen?
That is why I say on the specific Gen AI, he gets his data. On the multimodal, maybe people can combine use more than one time. It's okay now.
So we can also get from the multimodal thing or just generative AI?
It depends on the model.
Depend on the
It
model.
depends
We are
on
both
the
of them.
requirement.
Generative AI plus multimodal.
Yeah.
I'm doing both of them right now.
But we also have multimodal generative AI, like which already have generative AI.
Yes.
Yeah.
But I'm asking from like the separate generative AI thing.
Yeah.
Just for like if we use a single one and if we use the multiple one.
Okay.
If we use the multiple one, why we need like we can do the single one with the multiple or not? That's what I'm asking.
If you can do the single one with multiple,
Yeah. Like can we do that or can we not?
I have one doubt, like video. I think
you want to
related to
explain
that.
her question?
About that doubt only. So there is a video, it has video, audio, captions, everything. So
Yeah.
does it comes under generative AI or multimodal AI?
No, but you counted how many data types inside? How many data types? You said video, audio, text, and why do you?
Like generally, like a movie or whatever, it has everything right up.
Yeah.
So that it comes under multimodal
Yeah.
or a generative AI.
How many data types you counted?
Video,
Audio,
audio.
video.
More than two, so it's multimodal.
It's multimodal.
Yeah.
But in this
I
case,
feel that-
can
I
we
feel
use,
that- Yeah,
multimodal
in his
GIS?
case, he can use generative. But I think it's a packaging. It's like, when I-
And pro and con. If the project require both of them, you have to use both of them.
If
not,
you use multimodal generative AI rather than
Does it cover the
generative
generative AI part or not?
it
That's
will be
what
good
I'm
or
asking.
not?
yeah,
Because it
If
already
you
has
use
I
multimodal
understand. I
generative
think I understand. It's just a
In
packaging.
multimodal, we can
Generative,
search or
rather
we
than
can
generative.
generate something by
What
voice
will
or
be
by
the-
typing or by sending
We use
it to
generative
the
AI.
transformer like generates
I
it.
use two model. One is
But in
generative AI.
single generation, we only have one option, either typing
Get
it,
it
either
as a
voice,
I don't have.
either.
Yes, so I can get how many data set as I want from.
Multimodal.
Yeah, multimodal has very modality, and that one has single. So he's doing single now.
That's mean the image
And
the
multi
text.
has more than
Like
one.
one ID that allows you to get that. So you can
multimodal
like put the
generative
image and you receive the text.
But we can check and I think I can, let me see something like this. For example, you remember sometimes I explained about the self-supervisor, the weekly supervisor. I said some literatures can define almost same way. So they make some confusion about it. Yeah. But if I get your question very well, I gave some explanation. He uses a Gen AI to generate single data type. Him. But if you have more than one data type of it, I think it's not. It's multimodal.
The thing which I know was like, if we use multimodal generative AI, we are going to create multiple things, not a single one. And if we would use the generative AI specifically, we
So
will
you use
create a
just one
single
thing.
one. With the text form or the platform. I just wanted to confirm, like, is it right or not?
Yes.
Yeah, I think you take it that way.
It's
Yeah.
working.
No, it's correct.
Yeah, it's working.
But inside, let's look at that, what you call the Gen AI here. This one, it uses how many? This module uses.
Single modality.
No, he had put a single modality, but how many he used? Yeah, inside. Yeah, inside. How many modalities?
In generative AI, we use only single modality. That's either a text form or the image form, right?
Just one at a time.
Yeah.
Yeah. Modality.
Yes.
My question is pretty simple. I just wanted to confirm that in multimodal generative AI, like you said, we get the images, text form, and everything. So my question was like, why can't we get the single one also from this thing?
But you got your question because I think I don't understand that question very well. Yeah, but you got your answer. Yeah, but because so far as I know, then he uses just for single, and then multi used for many modalities. Yeah, but be careful. Think about, maybe there are some, I don't know if it's this kind of situation where there's a kind of paradigm definition like that. I don't know. So you have to check. I don't know if your question, maybe I don't understand it fully. Yeah. Okay, so now we have some kind of evaluation, multimodal evaluation. Yeah, but actually it's difficult to do that. Why difficult? Because you have some multi-objective outputs. Yeah, multiple objectives. It depends. Like in this case, for example, you have to check the relevance and then the fluency, correctness, and so on. Like in text and description, and so. But we'll see the metrics, yeah, the evaluation metrics and everything. Yeah, you have the cross modality. Yeah, cross modality ambiguity. For example, you have like a man with a glass and you have a person with sunglasses. Yeah. So when you say, for example, in this case, there may be a problem when you define a woman. Yeah. Or maybe some other person. These two things represent definitely the same thing. Whether it's a man or a woman or a person and so on. It represents a human with glasses. So there can be some kind of ambiguity. You don't really get exact prediction. Even in the text, sometimes you can find it that way. And sometimes you have some ground to, lack of ground to truth, yeah, from the output also. So there are many ways to evaluate. How can you evaluate this kind of model? For example, then you can check for maybe the first way is to retrieval. Yeah. So to retrieval, what do? You have to rank the relevant items according to the modalities. Yeah. So, and then you can use the recall, because we talk about the recall here. The recall is always a top K recall, which gives the percentage of the top K prediction. It's same for the Bayesian rank and then the mean reciprocal rank also. Yeah. And another way, another evaluation by task can be if you are evaluating captioning or text generation. If you do NLP, I think you should have done already blue or rouge. How do you call this? Like somebody say rouge. It's a French, you just say rouge. It means red in French language. Yeah. But anyhow, you have some, for text generation, then you have some matrix, like 5 or more, that you can use to evaluate text generation, yeah, for example. And then, however, these metrics do not always reflect the semantic correctness. So even though they can give some kind of value that is acceptable, but it doesn't mean that it's always like a human. That is why sometimes when you use some GPT and something, you can see that they have some issues also inside. Yeah. So I think we take some break, 10 minutes, and then we continue after. Yeah. So can you talk about your project, molecular project again, during break? Can you explain it? A little, maybe 1 minute or... Because yesterday I visited some laboratory in the building. They are doing something like that. They do some culture, cell culture, and it's different.
I had a meeting with pharmaceutical engineering.
Pharmaceutical. Yeah, because when I talked with Professor, he mentioned. So they can provide some data for you?
No, I already have the data. It's like a coding student, and I'm going to do it combined. I'm going to do the computer part, and he's going to make me understand the bio.
So how do you feel that is possible?
Yeah.
They understand the problem you want to solve?
The professor also thinks it's possible, and he wants to continue with this project.
Then it's fine. Because Professor mentioned it when I discussed with you last year. Then it's fine. But you make the molecule or you predict some properties?
Actually, like last time I made you understand the molecule thing,
Yeah.
everybody got it wrong. It's like when you see
But it's right because we are not
we don't
biologists. But I wanted to be medical doctor 20 years ago, so maybe.
actually, when you see a drug or a medicine, it has a molecular ID, right? So these days, like we get new medicines every day. It means a new molecule every day. So it's really easy to make a molecule, but it takes a lot of time and a lot of money.
Yeah.
Sometimes it takes like 10 to 15 years, sometimes 5 years. But what can genetic AI do here? It can reduce the time. Like from 5 years, it can
You are always
reduce
generative AI or multimodal generative AI. Which one are you using?
genetic AI.
Gen
Because I
AI.
only have text.
Just
it.
one
Yeah.
modality.
I only have text. it.
Yeah, text it.
Yeah, that's why I'm using genetic AI. So the thing it will do is like take the molecular IDs from the chemical data and create a new molecular ID. We already have the protein IDs. We have to check the binding score of that molecules we have created with the protein we already have. And if the scores lie between -8 to -11, we can say it's good and we can make a medicine on this one. That's only
But it's another process to maybe accept, to test
yeah.
after.
They can do it pharmaceutically, but for my project, I can go till the binding scores. I can do that. So further on, they can continue. They can go to the lab and experiment with that molecule because it already has that ID, like this. So it already has like everything here. But we
This is
yeah.
the IT.
Yeah, and we have to create this
Like
ID.
this, yeah.
And this is called a new molecule, and it's like this one.
Somebody did chemistry during undergraduate. Yeah. I reviewed some paper recently about exactly what you are doing. I can show you. It's already accepted.
This is ID, and this is how it looks like.
Yeah.
Because we know molecules,
Yeah.
but in texture it is ID. So we are going to create this one.
Yeah, I understand that you want to create this chain of this ID. But PG, we make sure that when you make the molecule.
We are making the molecule here. Like the
Physically.
ID. Yeah, because this ID
In the lab, in the lab.
I can't do that with my process here. And they will make it this in the pharmaceutical.
What are you got how she said she wants to make real molecule?
No, it's a real molecule. But you understand, I'm just saying it is a molecule. It's a molecule. You can't say it's an ID. It's a
Yeah, she explained now everything about the molecule. She wants to make proper ID of that molecule.
like this is a molecule.
Yeah.
Like how we can't understand this.
I understand.
We can understand this thing, and this has a ID like this one,
Yeah.
like which we can understand.
Yeah.
So this is same, this thing in easy words, like which we can understand. We can understand. We are creating this one, and then we will able to understand.
Like you are
also have specific yeah, and we also have specific protein ID for this specific EGFR protein. So right now we have nobody can see the you have the structures, right? This is a molecule. Do you agree this? This is same. We will not
discuss the report.
I'm going to make this. It's already here. It's not there for that specific problem which I for that specific problem, so how can I create this very we can make the structure. Okay. Can you understand this?
So, thank you. Okay. Okay, thank you so much. So I think we try to continue. Yeah, and then please always put in mind that we need to look at things differently this time. And then, you know, because recently last time we studied some explainability AI, so we can add it to our research, for example, to make it more unique in a way. Or today I invite you to try to look at using more than one modality and then do some alignment and try to look at another way to do the research. Yeah. So today she explained everything about her project. She will do, let's just assume she's doing a molecule, but we call it molecule ID. It's better like that.
Because we understand the molecule ID.
Yeah. But if
Go to pharmaceutical thing, they don't understand the
yeah, but for us, it's computer. Yeah, it's computer. So we just call it molecule ID. So she generates some molecule ID. No, she doesn't want to hear that. If you say, she said it's physical molecule.
No, not physical.
She said it's physical.
It means it generates the text name of the molecule, not molecule. Physical.
She said it's molecule.
Yeah, name of molecule.
Not name. She said it is. That's the problem. So
It generates the formula.
no, wait. No, just answer. Are you generating answer? Are you generating the name or the molecule? Yeah.
Formula of molecule.
No.
That's the molecule.
Yeah.
That has a formula because that's how we are.
It is not physical, just formula name of
Not physical. You eat a medicine, you eat a physical. You don't say there's a molecule in the air and the swing.
No. We got your point. No problem.
I think that to be safe, we just put in mind that she's generating molecule ID
Yeah, it will.
for us, and then for her and the pharmaceutical.
Some lab person will generate the physical.
No, she said it's already the physical. No, not. She said it's already the physical. That is the truth about what she's saying. You just call it ID, then she call it physical.
I can explain things, but I need a whole class for this now.
Maybe next class we will sit and then you explain it.
Just like if you come to me personally, I can make you explain. If I can make a pharmaceutical ingredient, person understand this thing, anybody can understand.
Oh.
She said she will generate the name of molecule. It means
No, she's telling you that. No. Okay, let's. If you don't want anybody to disturb, just accept that is a name.
That's why we can discuss.
yeah, and they will make the molecule.
Actually, because professor is really interested, even though that he said that prof is retired, but he's still much interested in this work.
Yeah, I just talked to him right now.
Yeah.
I did a meeting also, right?
Yeah.
But
Because he mentioned though the prof is retired, but he still wants to do this, so he feels it's very important. Yeah. So that is why but I was always since the beginning, I'm really positive because I think when you succeed, Donald Trump will come here, so that will show him the molecule. But now no problem. You explained already. We understood.
I'm okay with
You don't like him? Okay, no problem. Korean president will come to our laboratory. Yeah. So anyhow, I feel that. It's really good. It's really good, and then we can use this another way, and then you can use any of these other topics that we are discussing to change the way you reason and make some more significant. And yeah, I just pray that you finish within the time because it's a matter of time with the master's program and everything. Yeah, but sometimes when you want to do some convergent sciences and then you combine with some other specialties, it doesn't take, sometimes it's not so complicated. So you will not have to work so much and they don't have to work. It's instead the fusion of both things that will push your work far. Exactly. Okay. So, yeah, thank you so much for that. And then let's, we were talking about evaluation, yeah, how we can evaluate some multimodal models. And then we talk about many other ways and some kind of popular benchmarks and data sets, for example, yeah. So, but in terms of classification, so if it's just about classification, you can use some accuracy base. You know what it is, like how many correct prediction all over the amount of prediction, and then also you have some other ways. And then in terms of alignment, you use some cosine distance when I'm aligning to get exactly intersection and remove the other section that are not interesting. So some popular benchmark, for example, you have in terms of vision and language. So if you are doing computer vision, you can check these ones to try to see if you can use some image and caption and then all these things. So these are the types of modality. So you can use this data set to try something. Since it's new, I feel you have the potential to quickly achieve something than using some old, techniques like that. Yeah. Please think about multimodality. I think it's a good way. Even if you convince professor about your topic, after all, professor will not give you work or something. But this one is really important. I feel, think about multimodality. It's really trending. You will see when we discuss about some research topics now. Yeah. So I gave some, you can check this on your PPT. When you receive them, you can take some data set. Just read the description about the data set, understand how it is. It can give you some insight about what to do. And I believe reading papers is more important, for me, believe that it's more important than coding. My belief, my own personal. Yeah. So please try to look at these papers. And so some other data set you have like this one. Who knows about this data set? We know ground. And you have hateful memory, you know this one. Some kind of speech, hate speech and everything. You know it, Amon? But why? Turn on that one. Or this one.
You come here, please.
Or you sit here. I know you're handsome, but you can sit in front. It doesn't matter. He's very handsome, but he can also sit in front. So please, you can check firstly, then maybe sometimes it doesn't take 30 minutes to just read some data set description. It will not take so long. So you can check about some hateful memories about sentimental analysis. If you do in mental health and everything, you can just read. It doesn't take much time to read this, and it's well described there. Yeah, just this one also. Yeah, you just read about the description. When you read about the description, maybe you understand, or you can get some kind of thing you can do, or something like that. It may guide you. So I feel that if you use this, you use some of this data set, maybe combine with what you have before or something like that, you may do something a little different from what you have been doing. Yeah. So now you have some, for data, video and audio, you have this one. Yeah. It's the name, How to 100M. Yeah, this one helps to get some multimodal video and data set, yeah, for example. Yeah, so, but even though we plan to do this evaluation and use this kind of data set, there's still some limitation in benchmarking, yeah. One of the things is over optimization on leaderboards, and then lack of generalization testing. So sometimes when you go out of the area where it was trained, it makes this problem. It's also, it usually happen in computer vision problem. It means you actually train a model very well on a data set collected with some specific camera or slide scanner and so on. You even do some testing. They call it external testing. Yeah, but sometimes it fails to generalize. It's a big problem. That is why they say you must use some regulation before you deploy a system in real time. So just imagine you train with Peck Hospital. You train some cancer detection system here, and then you do the testing and everything. Then you deploy there, and then it happened to change the scanner. Maybe the scanner is bad one day, and the new scanner comes with some other structure of image, and every patient that comes is just a cancer positive. Yeah. So sometimes models have this kind of issues, but it happens more in this multimodality benchmarking also. This kind of problem you can have. Yeah. So, and then some very few support some real-time grounding. So maybe it doesn't work for industrial settings. In terms of benchmarking and evaluation, these are some emerging approach that you can check on, because we look at alignment. On alignment, I gave like 3 emerging approach, but in terms of this, you have this emerging approach, like this one, for example, you have some reference-free evaluation using LLM. This is a way to evaluate. It's a still ongoing research. So you think about it, yeah, and then, but this said maybe recommended for PhD students, or yeah, like that. And then dialogue-based evaluation. So you ask the model to explain the answer. Yeah, so people are doing it currently. All these things are referenced on Google Scholar. Always open Google Scholar, always. Just open it somewhere. It's very important. Yeah, and then grounded question and answer with explainability. So explainability, yeah, these are some kind of latest advancement in that field that you can look at. So now, let's look at another aspect, the risks and ethics and societal concern. You see, since last time, I think even in the first class, we always talk about this. Because it's nothing if your model performs well and then instead creates a problem in society. It doesn't work that way. Yeah, so you must demonstrate that your solution is acceptable. Acceptable means that user can trust the proposed solution. Yeah. So you will work on this, and other people focus on trust only. There are many things to research on. You don't need to do the same thing. Some people may be interested just in trust and fairness, and some people in acceptability studies and so on. Think about the number of, I think that at least everybody here have executed at least one model. So it makes 20 model here. Where is it working? Just in our computers. You see? But let's think about what makes people not to use it. Maybe you can ask that kind of question. Look at the number of medical imaging model, and you check how many hospitals and how many people accept to use. Because one hospital will use one, or many hospitals will use one model. But look at the number of papers that are coming out. So there is you may ask yourself, but some acceptability studies, there is something that makes the model not acceptable. And it falls under mostly not your coding, but about all the risks and ethics and this, for example. Who wants to do acceptability studies? Somebody want to try this with me? We do together. Model acceptability. It's very important. I'm sure if you do it, it will sound good. Think about it. If you're interested, you let me know. So let's look at bias and fairness, for example. So bias source in multimodality. So in this case, you have some trained data. Sometimes the large-scale web scrap data reflects to societal bias, for example, and then so some kind of modality leakage. So some virtual features cannot act like proxy sensitive. So you see, for example, the skin tone is reflecting to the race and so on. Yeah, I'm happy to be black, but some people don't like, and then some people don't want to be Asian and so on. So it does like that, and then it makes some kind of problem. And some cross-modal reinforcement, for example, cross-modal reinforcement. So when you want to leap from one modality to another, like textual and visual bias, yeah, so there are some, for example, associating a nurse with only women, but they're actually nurses that are men. So each time you talk about nurse, many people want to think that it's a woman you're talking about. But no, nurse is a grade in the hospital. Nurse is a grade. It's somebody who studied maybe nursing for some years or so. So it may be a man or a woman. What do you think, Yasin? Is nurse a woman only? Yasin could be a very good nurse. Because when I think you can make some molecule and something like that to cure people. Pharmacist, or you did not like it before? Just electrical engineering and computer. And then you will see that there are some other kind of bias, like for example in some when they talk about some kind of amplification bias, when they talk about CEO, mostly think it's a man, for example. Yeah, but Hajara really wants to be CEO. No, wait, maybe you won. If it's one thing, you should know if you won or not. It's not maybe. No, I'm talking about one thing. Do you want to be CEO? Just say yes. There's no maybe in one thing. You just thinking. Yeah. So if they say, like when you talk about Dali and they ask him to generate some kind of CEO, he just shows a man. Yeah. And then you always say white man. Yeah. Which is not so good. You need to tell him, please, make him black like me or something. Huh?
You will become the CEO.
Maybe already. Yeah. So some kind of fairness metric also, right? Kind of bias diagnosis in benchmark, fair face. Yeah. So if you look at this data set, you will better understand kind of bias inside. You see, yeah. And hallucination and misalignment. So hallucination, for example, a kind of cross-multimodal hallucination. So you generate some image caption that include object not present. Yeah. So it lacks, so the output lacks reality. It's so abstract, for example. Or for example, inferring sensing incorrectly due to some training correlations and so on. Yeah. So these are the kind of bias that you can have. Yeah. And then some kind of misalignment. You remember misalignment. Also we have some tool sets here. We do some alignment, but maybe we miss misalignment. So it gives some generation of conflict with input. So you may ask for a dog on the stick board, and then it generates some image of and shows a bear instead, not a dog. Yeah. Some kind of misalignment, for example, and unintended completion in the dialogue. Yeah. So these are some kind of things, like harmful or political responses. Also, data privacy and security, copyright and everything is not spared from this. You have data collection issues, web scale, and then you will see that some personal website, according to the country policy and so on, so they can collect some personal website photo names and social media screenshots and so on. Yeah, you can even see it from day-to-day life. You see, because before on the WhatsApp app, I think you can screenshot somebody's profile picture. But now it's not possible. In most cases, if you try, then they try to reject. It's not possible. Yeah. Maybe you use some other tools to do. Zia is trying now. You want to screenshot? You can try. Alan, do you try? Yeah. And so many things is changing. You can join WhatsApp community, for example. You see that they're always working, and you see that instead they are trying to solve this kind of societal problem also. They use still programming to solve it, but they are very important problems that we cannot overlook. It's very important, this kind of situation. So, and then personal consent information, copyright material using, and so. Yeah, because before, without the copyright, I remember on the Meta platform, it was Facebook that time, then many people monetize their platform and make a lot of money with some generated content or copied content even. But today it's not more like that. It's some kind of strict policy on copyright. So if you take something belonging to somebody, the benefit will go exactly to that person, not you. So they are able to detect the original source of a data and then try to reward instead the person who originally did it. So these concerns are very important in our society, so we cannot neglect them, always just trying to do Python, and they will solve it with Python also, so it's not a problem. And also some legal risk about unauthorized reproduction of copyright. I talked about it already. Yeah, and then inability to forget some redact content from training data. So if you do that, then yeah. But how do you solve this? You need to think about some way to solving is a differential privacy. So in this case, they make sure to use more descriptive text. You know, the text is more informative. Yeah. So when you are attaching, then they use more descriptive text than images. You see? Because when the text is more, and image can easily mislead you. At 50%, you can be misled with the image. But with the text, there's probability that the misleading 70 like that. But with image, it's 50 or 0. Maybe you just miss totally, for example. So, yeah, one of the ways is that they use differential privacy. Then, so they use a lot of text, and then they avoid some bias and also avoid some privacy concern. Yeah, because except from your book, your article, paper, and so on, it's hard to claim that the message you send to your friend is only yours. I don't think it makes any sense, yeah, for example. So if you use text, then sometimes you can free yourself. You know about politicians and so on. Yeah, sometimes some pictures. But when it's text, you need to justify something above the normal text. Maybe you need to show the whole conversation with his name, and they need to make sure it's really him. But when they take you in a picture, there's no way, just accept. I did wrong, and then you resign. You resign already from position?
No.
Not yet? Do you think it will happen soon?
No.
You don't want? Yeah, because it's disgrace also. But maybe in your country, people resign?
Sometimes resign, sometimes resist.
They resign?
Every time they just
They do?
He support.
No, like ministers. Ministers, they easily resign.
No, you say they resist.
They just want to stand forever. I know that situation. My country, I think resign is not in dictionary. Just some very few, yeah, maybe one or two ministers already resign, but yeah, everybody is hungry. They just want to be comfortable and feel free. Yeah.
Our country is protected, so that's why he didn't.
I see. Yeah, so this kind of things we can use always. We try, whenever we use some these solutions, then we try to use some differential privacy, then using more text, for example, and then federated learning is another way. Well, so you have to avoid mainstreaming multimodal training, and also dataset curation with licensing. Licensing is already because you have the protection of the data owner, so it makes that some kind of avoid some privacy issues and concern, for example. But what about the frameworks? We talked already about acceptability last time. So we have these two, I think you know already, these ones. From Europe, because we saw this last time, AIA and then GDPR, yeah. And you have some other one, FDA and so on, yeah. All of them, you see, they make some key provisions for XAI and multimodality, yeah. So they are very important legal frameworks that you need to understand, yeah, especially for those who want to be a CEO, because if you want to develop a service, I think before adoption, you need to, in some cases, especially healthcare and finance, I think, you must go till the end. But maybe if you are just managing something, it doesn't need to be so deep, yeah. Okay, so let's look at this one, some emerging trends now in this area. So I'm just suggesting this like some research areas. Yeah, if you are really interested in multimodality, yeah, why not think about multimodality agents? Agents, you know what it is, because Professor mentioned agent programming recently, and then some kind of interactive systems, yeah. So you have to integrate some kind of language reasoning and tools together, so an agent can see, talk, move, and do some other things. So it's a next generation. So I saw many people also working on this kind of situation, and there's also the multi-language and multicultural modality, yeah. So some cross-lingual alignment with modality. But you can see that GPT-4 already solved this problem. Can you ask a question aloud? You can ask a question now. Was it a question? Oh, okay. So some other research topics, look at this section, and then you can see that some people are trying to align the world knowledge and common sense reason already. Yeah. So maybe they start today and they finish around 2000 when everybody's dead already. It doesn't matter. We just participate and we do what we can do. Yeah. Because if you look at this multimodality, there are some articles of 50 years ago talking already about this. Yeah. So I think there are many things that we can try new. You said you needed something new, don't? Try XAI, try multimodality. Definitely will give you something new. That is very sure. With combining. Yeah, but each time, please, when you pick a project, make sure, think about the time that you have and possibility. So better take time to check whether you can finish. Take 2 weeks or 1 month to check if you can finish, rather than going into something that you will not finish, and at the end you don't have a degree and you don't have anything. Yeah, please be careful. And some topics are science-based, so they really try to advance science, but if you don't feel you can do it, just do applied science. So applying some techniques to solve a problem. Thank you so much.